All right, thank you all for showing up. I'm really excited to talk about this today. We're going to be talking about CPS and Cmake. Title's Marching Towards a Standard C++ Dependency Management. I prefer the capital M in Cmake. But the slide they gave me was wrong and I didn't fix it. All right, so a little about me. I've had 2 jobs in my career. From 1990 to 99, I worked at GE Research in a computer vision group. And I actually, when I showed up, I was the C guy because I had learned C from a summer intern job. So I was a Kernighan and Ritchie C guy. And I got there and they wanted to move from their symbolic list machines to C++ on Spark workstations. And later Linux and Windows. So I was using C-front, and this whole new object-oriented C stuff was really exciting to me, and it was really cool. But I ended up being the build guy and the software maintainer. Back then it was sort of Cmake, AutoTools sort of stuff, but then the Windows stuff came out. We had to figure out how to do that. There was lots of stuff. But then in 1998, I left GE and with 5 other people from GE, and we started a company called Kitware, and we do scientific computing software. We have a computer vision team, a scientific computing team, a medical imaging team, data analytics, and a software group that has grown up and built around Cmake. Cmake actually came out of a project we had with the National Library of Medicine, NIH, where we were creating a large C++ toolkit. And we were not mandated to create a build system, but given the pain I had at all those years at GE, and I really wanted to create a build system, we had the flexibility to create such a thing. So that started around 99. Mostly now I do pointy-haired boss stuff, if you're familiar with Dilbert, and finding funding so I can keep the Cmake team happy. So, marching towards standard C++ management. So I asked the AI to say, give me a good image for marching towards, and it produced this rather grim thing to my left here, to your left. And I was like, I don't think that's how I want to think of this. I was like, can you make it cheerier? Make it a little happier. And I like the one on the right. Yeah. Happy marching band. That's me. Everybody ready to be happy and be happy about CPS? All right, so this kind of goes back to a talk that in 2023 that Bret Brown, who's here now, and I gave at CppCon, where I learned that if you're doing a dual talk, you get a chair or something. Don't just lurk in the background looking really stupid for an entire talk that's out on YouTube until you get to go. And then, then I looked okay. But you got to admit, me lurking around in the back, I still get picked on by Pete. Anyways, we gave a pitch for this CPS, this concept. And I'm going to borrow a few slides out of that just for a refresher. So what's CPS not doing? Well, we're not doing a package archive format, like a deb, RPM. We're not trying to recreate those. We're not a package manager. We're not enforcing some source code repository structure, not a TOML or a Pitchfork. We're not prescribing workflows. Why not? Well, there's a lot of scope behind that and adoption friction. So this idea is the first step, right? We're marching towards this thing. And this was the low-hanging fruit. And it's, as you'll see by the end of this talk, it's borne some fruit, and it's pretty exciting stuff, at least to me, and hopefully to you after I'm done. So the goal is this first step towards a robust packaging ecosystem. Explicit metadata with a specification. Supports all architectures and environments. Supports multiple languages. We're not just C++, C. We should be able to do other languages as well. And making our projects as portable as the code they contain. So why is this an issue? So if we look at our 2024 annual C++ developer survey, if you add up the major pain and minor pain, managing my libraries and applications that depends on is somewhere in the 80% of people say that really sucks about C++. And then if you look at some of the other stuff and you add all that up, there's a lot of stuff with building and C++ that cause people pain. How many people in this room feel pain from? Who doesn't? Okay. There we go. Okay, so yeah, most of the hands went up. So motivation, why can't the tools just fix it? Well, the existing tools, they have limited context. Like compilers know what you gave them on the compile line. And the linkers, build systems, there's a caveat. In some cases, well-governed, if you have a monorepo or a specific system, you can set it up to do some of this stuff. But in the general case, it's a fuzzy responsibility of complex tools and projects. Who's supposed to be doing this? And a lot of these coping strategies that we've come up with in this community aren't portable. And that's one of the main things that Cmake was meant to be, was portable. So the next we have flag soup. So current methods of managing dependencies using compilers and linkers, labeled flag soup, becoming increasingly problematic, especially with C++ 20 modules coming. There's some lack of structure, relies on unstructured things that only the toolchain understands. Like if I have -L, some path, and I link to the library bill and a -include, that's not really telling me enough information. And there's composition issues if flags from different things could conflict with each other. There's ambiguities. It's difficult to express complex requirements, different usage requirements, static versus shared, different compiler features. And then, of course, modules make it even harder. Ben Bakel from Kitware wrote a paper on this, Dependency Flag Soup Needs Some Fiber. Good thing, good read. Go check it out. So moving beyond flag soup, the need for structured usage requirements. This has become something embedded in Cmake. Basically, it's encompassing all the necessary information to consume a project, compiler flags, link flags, environment files, everything in some package. So if I got my chips lib and then my chips consumer, I'm thinking potato chips here. I've got all the options that I need are in this. And I've got granular control to allow library authors to specify precisely what's needed to use that library. Context awareness can potentially adapt to requirements based on the target type, language platform, and provides a necessary framework to build for C++ 20 modules. So enter another paper that you can go look at. This was proposed by Kitware's Matthew Wolke in 2018, the Common Package Specification. This actually came out of a project we had at Kitware, a little history. People might not know about this. And one of the customers was using Bazel, and we were trying to figure out how to get Bazel to talk to Cmake, and Matthew came up with this idea, and then it kind of lay dormant for a few years. But let's talk about what a postmodern Cmake might look like. We can add Cmake support and have trivial upgrades replace. Essentially, if Cmake supports this, we can get the community to basically do a trivial update. And I'll get into some examples of what I mean by that and how that works. And we want to replace Cmake modules with a CPS JSON file. So this should be trivial for anyone who's currently using Cmake. So, they're just, in their normal upgrades, they'll use existing find package calls, existing install export calls, and then it should work with existing package managers as well. So it's not going to radically break everything. It's going to seamlessly work with everything, but then provide a huge benefit beyond that and beyond what's currently there. Easier Cmake interrupt. So build system interrupt and freedom. So right now, the Cmake export import packages and targets require you to be using Cmake. There are people that have other build systems that generate Cmake files for Cmake's consumption, but I'm not aware of any other build system that can read and parse and pull in a Cmake config file and understand how to use it.
Mason does, but it's just by using Cmake to do it.
Yeah, they shell out to Cmake.
We could generate, .in files. So it's a simple thing that you could create. JSON interrupt is commoditized at this point. You could do JQ calls from a command line interface. Could work in some cases. So people could create these files trivially. It's not, they don't have to know some new language. C++ modules need dependency metadata. So modules somewhat up the urgency of this problem. There are awkward designs for shipping modules. And right now, we don't want people to have to choose between dependencies and build systems. So lib format is only modular for Cmake users and monorepo users. That doesn't seem fair. It should be modular for everyone. Another thing that CPS brings to the table is to help with software bill of materials. It's a hot topic these days, ensuring software transparency, managing open source software and third-party dependencies, essentially knowing what's inside your software. Like the label on your granola bar, and you've got your ingredients. You don't necessarily have it. And then if there's a recall because they found salmonella in those peanuts, they can bring back that bar. But when they find that your software has got some critical vulnerability, how do you know which software has which vulnerability? The concept is you ship some software bill of materials with it so that you can look that up. And CPS would make it easier for this SBOM creation. So now let's talk about what's a library. So if I ask anybody on the street, what's a library? And they're like, well, I guess it's a set of header files. It's a CPP files. It could be a binary or static. It could be a dynamic library. It could be module interface units. It's got the linker units. People really do this too. There's like meta library. It does absolutely nothing but give dependencies on other libraries. So it's a whole bunch of things, and it's kind of hard to describe. Wouldn't it be great if we can answer that question by saying, see the contents of your CPS file? That's what a library is. And that hasn't been done to date. A concrete something we can grab onto and say, yeah, that's a library for C and C++. It's this thing that sits on the disk with a bunch of other stuff that you need to use it, but it's not all packaged together in one place in one easy to read format. So that's why this is low-hanging fruit. All right, and software is getting bigger and bigger. I love this slide. It's Todd Gamlin from the SPAC project put it together, talking about HPC simulations depend on icebergs of dependency libraries. So this cancer drug interaction modeling system has 98 packages with 248 dependency edges. How do you build this? And how does everything communicate with each other? These are real world problems. And this is a real world solution. So a quest for standardization, introducing CPS, the need for a tool agnostic, declarative solution for C++ dependencies. And we're going to introduce the Common Package Specification as a way to do that. Building upon the progress, there's a couple blogs out from Kitware and some talks. And today I'll talk about the significant advancement of CPS import in Cmake. So why this matters? We can get improved build reproducibility and reliability, easier integration with third-party libraries, streamlined development workflows, reducing dependency hell, fostering a healthier C++ ecosystem. We can reduce our build complexity, increase code reuse, modularity, improve long-term maintainability of projects, and essentially have a stronger ecosystem. All right, today I'm gonna look back a little bit at the historical landscape and talk about the renewed interest in this and the export, go into more detail about what CPS is, talk about what's in Cmake 4.0 with this, some of the current limitations, and then I'll try to get everyone here involved in the project, and we'll do some Q&A. So, the Wild West of C packaging. Early days, there was chaos and inconsistent approaches. Libraries often had their own unique ways of being consumed, if at all. Minimal or no metadata or dependencies. Copy-paste development, manual configurations were run-of-the-mill. How many people here built a make file from hand? Yeah, did you hard code the flags for the thing you used?
Of course.
Right, so this, was the way it was done, and it was part of the reason Cmake was created, to solve part of that problem, but then it became part of the problem. And another early attempt, as Vito pointed out if you saw his talk, if you didn't, definitely recommend going watch the video, that package config, why didn't Cmake just use package config? They kind of grew up together. They started around the same time. But this was introduced as a step towards standardization, relied on outputting compiler and link flags, essentially flag soup. Its strengths is simple, widely available, relatively easy to use for basic cases. Its limitations, semantic loss, not ideal for complex dependencies, lacked versioning, and difficult to extend. So if you just look at an example like this, if I do package config cflags libs for glib 2.0, it spits out this big long line. The first one specifying an include dir, and then an architecture specific include dir, and then a flag to turn on threads, and then I want to link, tells the linker to link against libglib 2.0 library. The L prefix is followed by the library name without the lib prefix and the SO extension. So it's kind of magic what's going on there. You really don't know what it's going to find either, because it depends on the capital L flag that comes from somewhere. And then you're telling the linker, I want to link against this lib FFIO, foreign function interface library. As you can see, even a simple single library like glib outputs contain a variety of include paths, linker flags, a whole bunch of stuff. But then if you start using multiple packages together with this, does it all work together? Who knows, right? A lot of times it doesn't. I can come up with lots of cases where the flags would conflict with each other when you try to use two packages together, because you've lost all the context. Sure, you've got the flags that tell you how to use it, but it's not enough. So I'm going to go over Cmake's evolution from find modules to config.cmake. So, and Qt is actually a really good example to look at. So in the original find Qt 3 in Cmake, there was a, inside Cmake itself was a find qt3.cmake file. Okay, who can tell me what the main problem with that is? Go, Vito.
So it's maintained outside of the providers of Qt. So Kitware are not experts on everything Qt needs. Qt has an upgrade path that's independent of your Cmake path. And so you need to move these things in lockstep, but they are managed separately. You upgrade Qt, now find Qt and Cmake doesn't work. You upgrade Cmake, now it can't find, now it does something different than what your version of Qt is expecting. Kitware doesn't want to maintain your package.
Right, exactly. Right. It has no business being in Cmake itself, and that the release cycles aren't going to be lockstep, and it's obviously completely impossible for Cmake to do a release when every other package does a release. It's just insanity. Only chaos is there. Okay, so then find Qt 4 was created. And this was actually a step up because its main job was to find Cmake in the path. And once it found Cmake, it ran Cmake and it asked Cmake where all the Qt libraries were. And then once it found those, it created imported targets. So it created Cmake's internal representation of a target that you could link against. And this was better because as long as they didn't change the interface to Cmake and we could still query it, new versions of Qt could come out and it would work. I mean, we still had a bunch of logic piled into Cmake that could break, but this was better. We were moving in the right direction. Okay, find Qt 5. Oh wait, it doesn't exist. There is no Cmake modules find Qt 5. For Qt 5, what the Qt folks did is they taught Qmake, at least for building Qt itself, to generate Cmake code. So it did the Cmake targets, and they wrote the code. So here we have another build system generating Cmake files and writing Cmake language, which was great for Cmake users because Cmake users can now easily use Qt, and it distributes and installs with Qt. But they had to write this weird language that they couldn't even use. So it's kind of weird, but this was definitely, heading in the right direction. And essentially, yeah, the Qt developers are communicating to Cmake via .cmake file. So find Qt 6. No, it didn't revert. That still doesn't exist. Qt actually moved to Cmake, and they got rid of Qmake. They went through a major build system conversion for this, and they just use Cmake's native export and install targets, and everything's nice. So the answer for the world is everyone needs to use Cmake, and then we'll solve everything. We're done. We don't need any interoperability. As Bryce said, resistance is futile. All right, so Cmake's evolution had this, going back a little bit, out of context there, but exported targets. And these targets had richer information about targets, include directories, linked libraries, file definitions, and more, enabling easier consumption of libraries within a Cmake project. The key limitation to this is it's tied to the Cmake script language, limited tool interoperability, and cross-platform adoption. But they still had really big benefits, and they define this sort of modern Cmake era of the target. And one of the big things they provided was whether I built foo inside my source tree or it came from another source tree and it was built, foo still looked the same inside my Cmake code. I said target link libraries foo, and it was the same thing, and it didn't matter that it was built outside or inside, which was a huge improvement over the old ways we used to do things, or like a package config thing where you just get a bunch of flags and stuff them on the command line, Hail Mary, and hope it works. So CPS, we're birthing CPS now. You're all here for the birth of CPS. And then, motivation, we want to overcome the Cmake specific limitations so that other build systems can use this. We want a purely declarative format. We're using JSON. So we have broad tooling around that. And it is inspired by Cmake's exported targets, but designed to be tool agnostic and language neutral. There's the paper on CPS I already talked about earlier. The vision, right? Everyone's got to have a good vision. We want a universal language for describing C++ packages, or C packages, or maybe even Python packages. enable seamless integration between different build systems and package managers, and promote a more collaborative, interoperable C++ ecosystem. All right, who doesn't want this? All right, one person didn't want it. He's out. But he was kidding, so we all want this. So, a new hope, renewed interest in Cmake export. Recent resurgence of interest in C++ dependency management in the community. There was the talk that Bret and I gave, and there's been a lot of other talks. There were some talks before that. We're realizing that this is an actual problem. Cmake 3.31 introduced experimental support for exporting CPS. So we're actually starting to implement this. And it's starting to get pretty cool. And I'll get to some examples that are pretty exciting. And this sort of is a crucial first step towards broader adoption. The experimental export, it's the first time Cmake can generate CPS descriptions, which is cool. Allows library developers to describe packages in a standardized way, and sets the stage for other tools to consume this output. The specification describing consumable software, primarily C ABI libraries, tool agnostic, designed to be used by any tool, associated with Cmake export targets, focused on declarative descriptions, not imperative scripts. So basically describing the what versus the how. It describes what a package provides and not how to build it. And it allows different build systems to interop with it. This contrasting with the Cmake scripts, which are in imperative language, and who knows what's in those. And we can also address some shortcomings. We have transitive dependencies, improved and more natural handling of complex dependency graphs, improved version management, flexible expressive versioning, support existing features like multi-component packages, configuration, interface libraries, and more. And as Matthew Wolke said, dependencies have dependencies. So if we look at a simple example, we have package K9 that depends on mammal, and we do find package K9, and it finds a k9.cps file. Internally, this will call find package mammal. And it could find an old Cmake, current mammal config.cmake or a mammal.cps file. So now they're interchangeable, which is really cool because if you've got some huge ecosystem that maybe is, and you're moving towards CPS, you can have the two live together. Do you have a question? No? Okay.
Excited for CPS.
Some important caveats. If CPS finds a Cmake script-based dependency, it has to adhere to the CPS naming conventions to ensure the correct resolution. There is a risk of partial imports if a transitive dependency is missing due to some limitations of Cmake handling transactional changes. If it's in the middle of something, it's kind of hard to unroll things. Current behavior makes all transitive dependencies available to the consumer. Future versions, we could restrict this and have ways of doing better encapsulation. CPS has a flexible version management beyond simple version numbers, support for version ranges, compatibility specifications, semantic versioning, enables tools to select appropriate versions, automatic based on the project requirements, should facilitate smoother upgrades, avoid version conflicts, and improve long-term maintainability. Okay, so in Cmake 4.0, we can finally import a CPS file. So this is a really big step forward. And you'll see in a little bit later, it enables some pretty cool stuff to happen really quickly. So we can import package information. It's still under development, but it allows for this end-to-end experiments and real-world testing. And we can get feedback. So it's kind of the old way, you'd have like 2 install commands. The new way, you just have one, where you install the package info examples. But key is this line down here, still the same find package. So we've got the same, yeah, go ahead, Neil.
So this is slideware, right? So it all
Yeah.
have to fit here. There's anyone who's written a Cmake export script knows there's also like 30 lines of code generation you have to do to make that config version file, to figure out all your dependencies in that example config file, right? It's not just simplifying the 2 install commands. It's simplifying all the work you had to do to set up for those, to call those 2 install commands. All of that goes away. You get one install CPS, done. I like CPS.
Thank you. And when you go to use it, it looks the same, right? The find package. And it's completely portable, you know, so if you've got half CPS, half not CPS, it'll still work. So why is CPS import crucial? It completes the workflow from describing it to consuming it, allows Cmake projects to use the libraries described in the CPS file, and enables interoperability between Cmake and other build systems. This is new, right? Cmake's never been able to do something like this, and allows package managers to start experimenting with it, and opens this two-way communication channel that Cmake never had. Like everybody had to talk to Cmake before, right? If you wanted to tell Cmake something, you had to write a Cmake file and give it to Cmake. Now, someone can write this JSON file and Cmake can understand it. Yeah, go ahead, Bret.
We should add that this also allows CMake to make more breaking changes, because CMake doesn't have to like ship you CMake scripts that work in your old version of CMake. So if both versions of CMake, you can import these JSON files, you no longer have to worry about CMake, like every package in your entire build graph having a compatible, like lingua franca for CMake. We're not planning any big breaks in CMake, but it's something we could start considering for like, oh yeah, that weird funky thing that you shouldn't have to do should we start. Like having feature flags to turn off the things that don't work, that kind of thing.
Yeah, we're not limited. The Cmake language API is no longer a limiting factor in how we upgrade packages.
Right. And even upgrade CMake itself to something. It's more hermetic, like which CMake you use or which CMake someone else uses becomes more independent in a very good way. So,
Yeah, that's a really good point. I mean, if we
Right.
change something in the Cmake language, it could potentially break all these config
right. So
files.
we're having real conversations about, like, should we look at a CMake tumble file? Is that realistic and things like that? And it's not active work, but like it's not something. It's something we could talk about. Right?
It's no longer verboten.
And yeah, this is the conversation here. If people want to bring up topics, feel free to interrupt and jump in. All right, so I'm sure you're all anxious to get out there and try this. It's really easy. It's an experimental feature in Cmake. So you need to set the experimental flag. And if you're playing around with Cmake experimental stuff, you'll want to go to help dev experimental RST file on the Cmake docs. And the reason we do this is, we got burned in the past. We throw something into Cmake, and then suddenly everybody starts using it, and then we want to change it, and they're like, no, you broke my thing. It's like, if experimental, we're allowed to break it. Because we're still experimenting with this. But we do want people to use it so we can get the feedback, so we can get the API right, so then we can take it out of experimental. So yeah, you turn experimental find CPS package on, and then use find package as usual. And it'll find and import CPS files from there. The eventual goal would be to have CPS support enabled by default, making it easier for everyone to use. And eventually, we can make it so it generates CPS files by default. And that'll have some interesting impacts as well. So, for example, if I go on my Mac here and I look for .cmake files in Homebrew, this is just a few of them that it found. But, this is how package managers look now. And they've got all these Cmake files sitting in their install directory so that Cmake can find them. But let's use the way forward machine instead of the way back machine. And then it might look like this, which is actually more compact. And maybe we'll see this in 2027 in Homebrew.
Why CSP instead of CPS?
Because I'm bad at making slides. That's funny. Yeah, because I did a find and replace on the .cmake and typed in the wrong thing. But I got a cool image of Mr. Peabody going in the future machine.
And it brings up an interesting point, which is because this is a more regular format, you can have a more trivial tool that notes that you don't have the CPS, you don't have a library named that because there's no file named that. Because again, in a very literal way, the library is the CPS file going forward. So you can say, show me other libraries in my environment. And it says, you don't have any. You're like, wait, that's not right. And then you could go look at, like, well, okay, where are the CPS files? You don't have, oh, wait, where are my CPS files? Right? So, like, this is kind of fun. It's fun, like, yeah, I've done this before. I did this for my slides. I made a typo. But people make typos in real code at the same time. And the fact that we don't have a standard to help people understand that, yes, you have a typo is part of the problem. So, anyway.
Yeah, that was intentional. So Bret would
Yeah.
bring that up.
Yeah.
How we plan. But the typos are more likely to be the names of things like, oh, you put a slash in your name, so now it looks like you have a directory and like stuff like that.
All right, so consuming the imported packages, it creates imported targets inside your Cmake project, just like it would with a Cmake import. And then use target link libraries to link your executables against the libraries in these imported targets. The component naming, so CPS uses package : component, but when it gets imported into Cmake, it converts to a : to match the Cmake way of doing things. There's a potential you could have a default interface target with the package name for simpler linking in common cases. So you could have a default interface target that links to this library.
That's especially for interop for existing package config workflows. That makes sense. People that use package config, like the thing that Bell says you shouldn't use. So that's intentionally like we're optimizing for adaptability. So if you're already using those names, if you have CPS files with default targets, you can use the same names, make that adjustment. Yeah.
All right, so Matthew's put together a really cool end-to-end example. You can find it on GitHub under the CPS org, CPS examples. It's called Cmake Z demo, and it demonstrates a CPS export. So it creates a CPS file for zwrap with an import that includes transitive dependencies to the z-test executable in sort of a realistic scenario. So this is a good place to start if you really want to understand what's going on here. And the first time I ran it, I was actually pretty excited because it was kind of cool. So we'll kind of walk through it. So our Z demo here, you can see that, so this is zwrap. So this is going to be our library. And it does find package zlib-ng. So it's regular Cmake thing, and it's going to find zlib somewhere in the system. And then in the install, we're exporting zwrap. And then there's some code over on the side that's in the header file that does our compression by calling the zlib-ng library. And then in our demo, we just we call find package zwrap required, and this is going to find zwrap CPS, but it's also going to transitively find zlib.ng. However, it was discovered in the other package. So if I this is just the build and install of zwrap. I put some to make it fit on a slide, I took some stuff out. You can see it, Cmake warning you that you're using an experimental feature, basically to keep you from actually deploying code with this, because we might change it on you. Build files are written performing the build step, and then it doesn't install, and you can see it installs the zwrap.h, the header-only library, and zwrap.cps. But really, zwrap is, what is the library CPS, everyone? Zwrap. It's zwrap.cps. Yeah, question?
Can you go back to the, I think, 2 slides? I just want to see this a little bit longer. You're only specifying the zlib ng dependency once, right? Not when you're also exporting?
Yes, it's transitive. So Cmake
Yes.
knows that zwrap depends on zlibng. So when it exports zwrap, that comes along for the ride.
Yeah, you don't have to do anything extra there. Just happens. So we do a build and install. And then the test configure. You can see that it goes through, it gives you the same warning, builds it. And then if we look and see what it did, you can see that inside a directory, it's hash thing, it's got zwrap.cps, which was created. And then when we install that, it ends up in the installation directory. And here is the CPS file. So we're saying components, it's zwrap, compile features, C++17, includes, at prefix, @/include, so it's relative to where it's installed, saying it's the include directory. And here requires zlibng, zlib. And it's an interface library. And it's got the path to it.
That field is so it can calculate the prefix.
Right. We got a name, and then it requires the zlibng and the components zlib. So if we look at that zlib installation that I built to get this to work, and then you can see it's got regular Cmake config files. So that's where Cmake got the information. So CPS is interacting with the older style Cmake config files here. And then if I look in my cache file on ztest, you can see that the zlibng path points to where I installed zlibng on my machine. And that happened automatically and got transitively pulled in. But obviously, there's still areas for improvement everywhere. CPS export is currently only supported for installed packages. So we don't, what that means is you can't do in build tree CPS like you can potentially. We could look into doing that.
There's some facts that you could implement, like the Python style editable installs. If that makes any sense to people. Yeah. That's a thought. No one's tried. Maybe there'd be rough edges that it's not worth it. But if you're interested, check, contribute, jump in, see if you can. Maybe you'll beat us to it. That'd be fantastic.
There's issues with exporting both Cmake and CPS formats. If there are cross references between the exports and requiring careful workarounds. The C++ module support in CPS isn't yet implemented, even though that was one of the main features we were going after, but
At the very top of my to-do list. Very top. Just behind all the other things.
import limitations regarding transitive dependencies and the potential for partial imports that I mentioned earlier will need to be addressed for robustness.
I think a way to summarize some of those concerns is we're just going to need like escape hatches for a lot of things. You can say like, I know this dependency is kind of weird. I'm going to overrule these particular fields, or I'm going to tell you that this is the CPS file you really want. Like, as we transition, that will be more important. As people converge more on good habits, it will be less important. The other area for improvement I'm going to make sure we have is more detailed and more specific diagnostic messages around your use of your dependencies. So if we can tell that there's a malformed CPS file, we can tell that you have headers, but you didn't have any include directories in your CPS file, like those kinds of mistakes will be trivial to check. Non-trivial to check in the config.cmake file, because you got to parse all that Cmake. that's super trivial for like JSON files. So those actually really low hanging fruit. So one of the reasons you might consider CPS really quickly is just the quality of your warnings about your packaging workflows will go through the roof compared to what we can do right now.
Also, many of these issues are Cmake specific, right? If you want to go out and build your own build system that's fully declarative and you want to build it around CPS, you won't have these problems that we have with like partial imports or conflicts with existing Cmake configs, right? If you want to go implement this in Mason or Bazel or something, like these aren't restrictions of CPS. This is restrictions of 2 decades of Cmake legacy. Like,
in the current implementation.
Yeah.
I mean, this is new code.
Yep.
You know, it's hot off the presses, and it's not.
On Bazel, but we're also targeting Cargo and setup.py and all the other ecosystems that want to be able to use these dependencies coherently. So, like, it's a very real use case. It's not hypothetical. You in a simple build system. It's realistically, people have a build.rs script, which is everyone is kind of its own custom build system, but they should be able to just use a crate and go CPS and move on with their lives, right? Right. So
we're done hijacking your talk. You can continue, Bill.
I mean, so like anyone that might be listening that's really into Rust interop, this is jump on. This is where you want to be,
right? C++ 20 modules. You know, a little pitch for them. No more include what you use, as Vito says.
Is it going to be port what you use?
Yeah, it'll have to be
port what you use.
but we can put fields in your CPS file about I export these import names, and then the thing is super simple. Yeah, that'd be fantastic. Anyway, we're moving on.
Yeah. Anyways, there's lots of issues with C++ 20 modules. This isn't to talk about that, but I'd throw it in there and say, you know, we can address some of this with CPS, and we will in the future.
I think that, like, just to be specific about the include what you use for the standard library cleans up things. So, like, you used to include it from this header, but now you can't. It's not from this other header. We've had to phase it out in the last few releases for certain tool chains. But to Bill's point, once it's just import stood, and if they want to rearrange their files, it doesn't affect you, would be actually a pretty big win for the ecosystem. So we can move on.
All right, this is really cool. So CPS and package managers. Both Conan and SPAC have got have been playing with these new features. And this is a slide from Diego that he presented at CppCon in 2024. He said I could do it as long as I said he was awesome and that he allowed me to use this slide and to give him full credit. So he is awesome. This is a great slide. I really appreciate it. And he had a cool little demo in there that we got to try. So the first thing he did was just, does this really work? I'm going to have a round trip. Cmake creates a CPS, and then Cmake reads the CPS. So he created a little my package, and with an example. So a package and an application, and then basically, we're saying target file headers, then we install the target to export to my package, and we're doing this install package info. And then over on the other side, we're finding it. So pretty straightforward. And if I run it, you can see that it did the install tree, has mypackage.a, mypackage.h, most importantly, defining the library in mypackage.cps and mypackage at release CPS. So that's where the library information is. And then here's the consuming project. Just configures like normal, finds that CPS file, and then I can run the example. Cool. All right. The second demo is a little more interesting. So what if we were to teach Conan to generate CPS files? And that's exactly what he did. So he added a way to generate CPS files and created them for basically any package in Conan. But this small example we did with zlib and bzip2. So, and now because Cmake can read CPS files, this is really cool. We can now have this package manager create CPS files and then have Cmake read it. So we've got a small executable here, our example, and we just have our Cmake code. We turn on our experimental support for enabling find CPS and find package, and we find zlib and bzip2. We create an executable that links to those. We do a target link library, zlib : zlib, bzip2 : bzip2. And we run Conan install. We get a bunch of nice colored output, and it builds the target, and it runs the executable that shows that it's linking zlib and bzip2 with these simple command here, giving the install prefix, giving the Cmake prefix so it can find the CPS file. So pretty straightforward, pretty neat, because now we've got another tool telling Cmake how to find a library in this new format. Similarly, we've been working on the SPAC package manager. This is a package manager that was developed at Lawrence Livermore Laboratories to address dependency hell, that giant iceberg of dependencies for building on supercomputers, which are really rare, interesting beasts that have rare and interesting compilers and all kinds of issues. Like you have to build everything from source because there aren't standard distributions on them, and there's all kinds of issues. But it's so basically you can. This is experimental too. John Perrin at Kitware has created SPAC CPS. This will get upstreamed into SPAC because they're interested in supporting this. So I git clone SPAC. I source my SPAC setup environment, and then I ask SPAC to install zlib and bzip2. It goes off and does that, builds them from source, and then I just say SPAC load zlib and bzip2, and that sets up on my environment so that I just run Cmake in my project, and it is able to find zlib2 and bzip2. And then I can compile it and run the executable and get my output. Pretty cool. Bloomberg, I mean, I kind of caught this slide together. Bret can probably tell you more about it, and maybe he will. But essentially, Bloomberg can generate .pc files, package config files, from the Cmake target model, from their Cmake system, and that's how they communicate, which is maybe one of the reasons they're helping to fund this CPS effort. But with a small change, they can generate CPS files. And they could do this over 20,000 C++ projects. And we can start to test CPS at scale.
We're doing it across multiple build systems. And again, like I talked about validation, we are performing validation about the relationships between these dependencies in the graph model. So I can see things like, is there a cycle? Can I generate like a graph-is diagram with the entire library hierarchy, like things like that. It was very, very fast to implement. So like, again, I think this might be it might be enough for some of these abilities, like these convenience things. It might take a little longer for people to get to the point where they can just go straight to CPS as the only way to do builds. But these kinds of analysis tools, these kinds of interactive querying tools will be the way we get there, I expect. But you'll get a lot of upsides in the meantime too, because you'll know, oops, you had a typo, your name didn't match the name of the other thing. Like you'll actually get some help with that. Which you don't get enough help in the Cmake land because it's a Cmake script. You just get, cannot find thing. Like, what does that mean? Like, oh, we'll read a lot of Cmake code.
All right, CPS, Cmake, and SBOM. So software bill of materials is a formal record containing the details and supply chain relationships between various components used in building software, essentially the ingredients label of the software. Here's a snippet for hello.c of an SPDX3 SBOM. Some things this SBOM tracks: source files, binaries, build tooling, linkage, origination. Where did you download these files from? So software bill of materials. So Cmake already tracks through the Cmake file API, added in 3.14. Originally for IDEs, but it has about 80% of what SBOMs need. But we're missing some pieces. like origination and a way to talk to a package managers. And hey, maybe CPS can come in here and help us with the origination of the files we're finding. So I think that the two actually go really well together. And you can imagine a world where the CPS files have a little more metadata and you can generate an SPDX SBOM.
Yeah, I expect that it's going to be more like reference to a writer file,
Yeah.
like on the side, just so,
Yeah.
so it lets cache also in certain ways. Like sufficiently advanced build systems will notice you read the CPS files and you invalidate builds because the CPS files changed, and you don't want to like rev the version because the timestamp on a thing changed in a way that does not affect your source builds and stuff, right? So if we have this, it'll probably look like, hey, I have some more extra like origination information. It's in this JSON file right next to me, and it was like, okay, and then they'll take it from there.
The intent is never that you are shipping SBOM. The intent is that CPS carries enough metadata in it, plus some things from the file API for the actual build you end up doing, that it is possible to generate an SBOM for any given build, right? Which is a reporting requirement for a whole bunch of people.
For more people all the time. And like it's worth noting that it's possible that you downloaded this from a binary, and the reference might be, oh, you can download my SBOM for this library at this URL, or some kind of URI reference, right?
That's
so maybe you just take that and you stitch it all together, and you have a big SBOM for the next thing.
It's ellipsed out, but most SPDX IDs are just URLs that point to other stuff.
Right. So the CPS file might have a URI for this is the SBOM for this release, and it could be a file on the disk or something, and then anyway. This is active area of research if you're interested. There's a lot of cool stuff we can do.
And this is Cmake file API snippet for exemplar. Got to bring Beeman into every talk. Right, because we get Bret kudo points every time we do it. Yeah. All right. And software bill of materials is actually something we're actively working on adding into Cmake for another project that we're working on. And it will be as simple as install SBOM format SPDX. We're hoping this to land as experimental in Cmake 4.1. There's a lot more work to do, but we are actually working on it. And I'm looking forward to CPS interacting with it. But they're both kind of happening at the same time, but we live in exciting times. Okay, yeah, the future is bright and collaborative. The implementation is active and ongoing project with continuous improvements, community contributions. We're encouraging experimentation with people trying both the export and import in Cmake so people can gain practical experience with this. I know just putting this talk together and trying some stuff, I found some bugs. I found some bugs that Bret found a month ago. I felt really bad that bug didn't get fixed. Went to Vito. I'm like, am I doing this wrong? He's like, no, you're doing it absolutely right. Look at this issue. And user feedback is crucial to shaping the future of CPS and ensuring it meets real world needs. So reaching out to you in this room and you on the internet, watching this video someday, reach out, try CPS, see if it works for you, throw rocks at it.
Especially bugs where it doesn't work, like as documented. Things that you think are getting in the way of you using it. Like, help me, I want to use CPS, but this dependency does this weird thing, and I can't wait for this dependency to be fixed before I use CPS. We're like you. We have to invent things. Cmake will invent levers for that. They might not be in the CPS spec, but Cmake itself will need ways to say, override whatever the CPS files need, or use this other CPS file I wrote something, right? We'll have to discuss what works for you, though, right? And then, Bill and I are excited about SBOMs for CPS. What are the use cases for using the metadata that excite you? Like, how should it be prioritized? Maybe you can contribute, like, what's the field for that info, that kind of thing. So there's some really obvious stuff that we haven't gotten to yet and you can help with, like conflicts. Like should this CPS file never be used with this other CPS file? We could express that now. We never could before. How do you spell it? Should Cmake support it? How should it support it? What should it tell you if it sees that kind of stuff? But like Bill and I are doing a lot of stuff, but we're trying there's a lot of cool low-hanging fruit that other people can jump in on, is what I'm saying.
Yeah, we want to support other artifact types, executable stuff, improve the version resolution algorithms, integrating with other package managers, formalizing that, and become the default for Cmake. So this is really key to sort of the responsibility of being sort of the de facto build tool for C++. I think selfishly we could say, I want to keep it as .cmake files because that's going to force everybody to stay in this ecosystem. But that's not what Cmake was about. Cmake was invented to make everybody's lives easier and to promote interoperability with software. And I think this does that, and it gives us an opportunity because, like I went on my homebrew, and there's a whole bunch of .cmake files in there, right? These config files. I can really see a future, maybe 2, 3, 5 years down the road, where all those are CPS files, and they're not all generated by Cmake. They could be generated by the package system. They could be generated by Cmake. They could be generated by Xmake. They could be generated by who knows what.
They could be generated by Python builds.
Yeah, they could be generated by anybody. But that will be the lingo franco of libraries in the future. And Cmake can have a big role in this because it has such a large install base. And if we get it right, and that's why we need people like you to test it, if we get it right and we get it so that even things like, I'm really interested in hearing I've got a Cmake project and I tried to change it to export and import CPS files. And I ran into these issues because of my code. That's the kind of stuff we want to hear. Or, it didn't just trivially work for me. I had to do all this weird stuff that I didn't expect that I'd have to do. We want it to be trivial and almost automatic and silent for people to do this so that we can, flip the switch someday and then everybody's using it.
Right. And we know we have a mental list of a lot of these things. We need you to use it to also let us know which ones are the most important, which ones are blocking the most, so we can work on it first. For example, I know that a lot of you depend on Python code, but linking against Python. How do we model that in CPS? Can we do it with the things we have already, or do we need to invent a special field for Python just because it's so weird? And but we need people that are using it different ways to reach out and talk to us and try it out and say, yeah, that worked. No, this didn't work because I did this on this repo and I got that, right? So we have to I don't have Bill and I don't have all the use cases you do, and we definitely don't know how important they are to you. So that's where we need some partnership on this.
Also, Kittler's model is reliant on many eyeballs for a lot of things. This is a little bit of embarrassing story to tell, but the very first time we implemented CPS import, we had tested export using handwritten CPS files, and we had tested import using handwritten CPS files, and it hadn't occurred to us to test importing the files that we exported, and round trip didn't work until it was tried by coding, and they were like, hey, this round trip doesn't actually do anything.
And Diego makes great slides.
Yeah, and Diego makes really great slides. Many eyeballs makes the ecosystem better. And if you can't, even if you're not interested in diving into the C++ 11 code base that is Cmake, experiments help us flush out bugs earlier, which makes it more useful. It accelerates our adoption curve.
Well said. So get involved, contribute to the evolution. We just covered a lot of this stuff, but report specific issues and discussions on the CPS repository, help refine the standard and clarify ambiguities, report Cmake implementation issues on the Cmake repository to help improve that tool, engage with the C++ ecosystem evolution group. There's a mailing list. I'll have a link to it later. It's a Slack channel for broader discussions. And then we have, is it monthly?
We have a monthly, yeah.
We have a monthly Zoom call.
If there's enough demand, we can step it up for sure.
Yeah. So join the party. Help the revolution. So CPS reference docs, good place to look. CPS project. There's Slack channel, the hashtag ecosystem evolution. It's a mailing list. My slides will be available. I don't have a cool QR code like Bret, but I'm not as cool as Bret. So.
This is fine.
Ecosystem ISO discussions on the I don't know. Does that actually get used anymore?
That last one, we're moving that to a new repo, and we can talk about that in extra time if people are interested in
Okay.
where that's going.
There's a couple blogs that just came out. They're on the the Kitware website. The first one came out in October 2024, a year closer to standard C++ dependency management. It's a good read. I covered a lot of what's in there in this talk, so you sort of got force-fed what's in this blog, but still a good read to go back. And then navigating Cmake dependencies with CPS, which used to be called Dependencies Have Dependencies, but someone in the Kitware marketing team changed it on me without even telling me, and it like broke the links. And now there's a link, so both of them end up there, but I've been traveling so much, I haven't figured out who did that or why they did it, but I guess this sounded better to the marketing folks. But kudos to Matthew for Dependencies Have Dependencies.
Get a mailing list so people can find you and tell you it was broken.
Yes. People reached out to me and let me know. So yeah, quick summary, tool agnostic, transitive dependency management, flexible versioning, declarative approach, and improved interoperability. Cmake has come a long way in this front since the 2023 CppCon. If you remember, Bret, we had a load package, CPS.
Or something like that, but not normally. Yeah.
And I gave this at our talk, and then I ran the demo and said, ta-da! And we got a round of applause from a huge room for running a hello world program. So I guess people were excited about our talk, but now it's come a long way, right? It can do a lot more than that simple demo, so we should get more applause. We can,
You can install it.
yeah, we can actually use it. We can export it. We can find it. We can do transitive dependencies. We can run it in Conan, and Spec can now talk to Cmake in a more intelligible way than, like Spec's like shoving flags down in a compiler wrapper or doing weird things, or injecting stuff into the Cmake code through abusive tool chains. We've got Bloomberg trying it at scale. So it's really come a long way, and it's exciting to see that we're actually moving forward with this.
Right.
You can go and there's some Cmake docs. So the find package has now CPS transitive requirements. Probably want to go read those. The package info format of install creates the CPS files. So with that, Cmake and CPS, like peanut butter and chocolate. I don't know. And we'll open for questions and any other discussion if people want to talk. Or we could be done. Yeah.
You mentioned one of the limitations at the moment was not having CPS for build trees.
Yeah.
It was only for install directories. I have a use case for that, but I'm curious what you have in mind. Like, why is that a limitation? Is that so that
it just isn't implemented?
It's a feature we would like. But Diego was one that brought it up. The same Diego that has amazing slides. He's like, I would really like for like my Conan workflows that in the Conan built things, it could just make CPS files in your build tree.
So he doesn't have
like
to
an
install.
Editable Conan install workflow. So you can say Conan install my current package while you're still editing it, and like your dependencies still build fine and things like that.
There's a couple of it's all the normal. So if you never consume anything out of a build tree, I applaud you. Excellent. Continue to not consume things out of build trees. Unfortunately, there is one or two valid use cases, mostly related to cross compilation. A place this comes up is you are doing a cross compilation. You need to compile a tool like a code generator or something, and then consume that tool as part of compiling for the target, right? And so the way we support that in Cmake today is we have what's called an export command, which produces a package from a build tree. You can't do that with the CPS today. You can only do that with native Cmake script. Now you might say it's all within one build system, so what does it matter? But that's a kind of ecosystem. Then contrast to something with like LLVM, which does entire massive operations out of the build tree, and their build tree is correctly structured that it acts just like it's a system directory, right? You can't consume those style of LLVM dependencies out of their build trees via CPS today, because again, we just don't have any way to express what a build tree is in CPS right now. So the use cases personally, right? You come to me and you say in the hallway and say, Vito, do you think this is a good idea? I say, no, that's degenerate, but it exists, right? And therefore, in the spirit of Cmake always saying yes to everyone's use cases, we are interested in supporting it.
Well, the use case in like Python is
the editable source tree is maybe the one non-degenerate use case.
You want to use as close to what the user is doing as possible when you're doing your interactive development. So if you make mistakes that break your packaging, you see that while you're doing interactive development. For example, you might add a header file, and you might forget to put it with the other header files in your giant list of header files. What does the user see? Well, they don't see that header file installed, do they? But if it's in the CPS build tree, you would see that because something would say, hey, you included the thing, but it's not a thing. It's not in the CPS file. But that only happens if there's a CPS file in the loop while you're doing your interactive development. So that's one use case, but there's other ones. So that's maybe where Diego's thinking. He probably has a slightly different use case in mind, I would guess. But it would be a lot more efficient than built my thing, installed it, then I built another thing. Oh, wait, let's go back and start over because I forgot. I had a small typo in my Cmake script or something like that, right? So it's about a productivity thing, and it's about again shifting left the kinds of mistakes that are easy to make. It's a typo, it's an oversight, that kind of thing. It's your LLM hallucinated. How do you find that faster?
Funny you should mention the cross compiling, because that's actually where the import and export of targets came from. Mm-hmm. So it was on supercomputers. Oftentimes you had like a head node and then the other nodes, so you had to do this cross compiling. So the national labs paid us to figure out how to do that, because VTK itself had, our visualization toolkit that Kitware has a automatic C++ to Python wrappings program, and it's a C program, so you have to build it, but you want to build it with the local tool chain, and then you need to cross compile, run it, and then do the cross compile in the code generation. So we created a way of essentially like building that subproject and then importing it. But that's where the original concept of import export came in Cmake. But it turned out it's a
useful generalization.
Useful everywhere, yeah. Not just for cross compiling. Any other questions? All right, with that, we'll call to close. Thank you all for coming.